All right, another tricky thing I wanted to clarify. There was a question that was about the fact that when you define default values for parameters in a function, this assignment only happens once. And I'll explain what that means. So let's say that we didn't know about this tricky situation, and we just try to predict what the output of this code is. We've got this function here, and we want to call f 3 times, right? So you would expect that the first time you call f, well, we get our L, okay? And that points over to this object that is a list that's empty initially, right? Because that's how it's defined, that's our default value. We didn't pass in any parameters, so L gets its default value. Then we append 1 to it, and this plus equals, remember, modifies the existing object. Okay, so we modify whatever's over here. We don't create a new object and reassign. The meaning of the plus equals operator is that it modifies the existing object. It's basically the same as L.extend. Then we print that out. What does L look like? Well, it's this. Okay, great. Now, once we're done, well, we've called it, and this L, by the way, we should probably be more careful here. This is the script itself, you know, where f is called. This is the frame in the stack that is corresponding with the function f. So here's the script part of the stack. Okay, so this local variable L disappears, right? It goes away. And so we would think that, all right, this goes away as well. And then we say, okay, we think that we call the function again, f gets called, L appears, and L gets its default value, right? And so we end up with nothing, and exactly the same thing happens again. We think, all right, 1 gets appended, and it prints out. So we would think that this prints out 1, 1, and then 1. But that is not what happens. And the tutorial explains that the reason is that this only gets evaluated once. This is kind of funny, right? So this is actually what goes on. Let's draw the diagrams corresponding with what actually happens. Okay. Stack, heap. Here's the script part of the stack. And we call the function for the first time, or actually, I should say, probably even, I'm not sure exactly when this happens, but probably even before we call the function for the first time, probably when we define it, is this happens. So we get some variable L that corresponds with the function f, and this makes sense if you think about the symbol table, if you read any stuff about that. Well, we're adding f to the symbol table, so apparently somewhere inside here, or maybe we've created some sort of object that is the function. I don't know exactly how things are working under the hood, but at the same time this gets evaluated, it's my guess. And so we get somewhere in a special place in memory that the interpreter remembers corresponds with the default values of the arguments. Somewhere in memory we get this object that is empty that L will end up pointing to. Okay, so when we call the function, it's not really important when it happens. It could happen the first time, but it only happens once is the point. We get this local variable L, right? And L points over to it. This was only created once. Keep that in mind. Okay, we end up modifying it. Okay, we modified this. We print it out. Certainly, you print out just 1. No question about that. The thing is, this goes away, right? You finish the function, and L is no longer pointing to this, but it turns out, it said, this only happens once. This object only gets created once. This is really what I should say. It says something about, no, this is what it says exactly. It says the default value is only evaluated once. So whatever you have on the right side here, this only happens once. That's what it says. It's not that this assignment only happens once, it's that the value was only evaluated once. The thing on the right-hand side is only evaluated once. It got evaluated already to the empty, and we modified that object. Okay? It's not going to get evaluated again to this empty thing. It's going to look in the same place in memory where it was last time. All right? So, when we call up L again, or F, we get our local variable L, and it points to that special place in memory that the interpreter remembers corresponds with the default value. Okay? The interpreter remembered where the default value was stored. We modified the default value. Because the default value is a list, and lists are mutable, and we modified it in here, we modified the object that is the default value for that L should refer to when we create this function. That thing only gets initialized once, and if we modify it, we've changed it for future evaluations. When we call the function again, we do create a new local reference variable L, and it just refers to that place in memory where that thing that started out as this still exists. Apparently it doesn't get garbage collected because it remembers that it needs to stay there for future evaluations. All right, so when we call this again, we say plus gets 1. Well, we got to modify it. Okay, and we print it. The second time you print it, it's going to be 1, 1. This goes away. Okay, so this does not go away. It stays in the same place in memory where the interpreter knows that whatever, if there's no arguments passed into F, then L, which is newly created every time, L is going to end up referring to this thing, and this thing is not going to be recreated every time. It will not evaluate this part every time. It's just going to point to the same place in memory where it was before. And in this case, when we create our F, frame of the stack, and here's our L, this is our third evaluation, we point over to the same place in memory as before, and we modify it, and then we print it out. So the third time we print it, it's going to be 1, 1, 1. Now this is a very tricky thing. This is not something that you're going to end up with very frequently, but that is how it's going to work. And so that's something to remember, is that if this thing on the right that you assign as a default value for any of your local variables, these are local, they get created every time, but if you assign this is an object on the right, that's only going to be evaluated. Whatever you put here, you could call a function to get that value, you could create a new instance of a custom class. In this case, you're creating a new empty list, but that is only going to be evaluated once. And in this case, that one time it gets evaluated to a brand new empty list. I'm repeating it so many times, I know. But you modified it. So it's always you get reassigned the same object every time. This L is going to get assigned to the same place in memory. All right. So how do you get around this behavior? What if you wanted this to effectively become empty every time? This is what you do. The trick is to rewrite this slightly. We're going to keep def F, but we're going to say that L's default value is instead none. Okay, something immutable. This is the idiom way of writing it. It's like an expression that is commonly used to do this. They choose the value of none, but it could be in principle, anything that's immutable. Yeah, so you make none the default value. Okay, something that can't be changed, and then you say if L is none, then L gets this. And then we change it, right? We say L plus gets 1, and we print it. All right, so when this gets evaluated, we've got the frame of the stack corresponding with the script for F, F, and F. But that calls the function F for the first time, but none, I should probably say, be consistent. I think that when we define this, we also, create the object none. Okay? this none here. This gets evaluated only once. And it knows that whenever we call the function f, if it doesn't get an argument passed in, then that local variable L that gets created is going to point over to this place in memory. So there's no pointer pointing to it, but it knows, I'm not going to draw one, but it knows where to find it somehow. The interpreter does. This is not hanging, this is not eligible for garbage collection, apparently. Okay? It's a special place. So maybe this is a special place in the heap, I'm guessing. And then we call the function f, and we have our local variable L. And, okay, L gets its default value of none. Okay. If L is none, L gets that. This, when this has evaluated, it creates a new object. It creates this new thing here. And this gets reassigned. It created a separate object. Notice I didn't modify this. This special thing here does not get changed. I created a new object and L gets that. And so we say L plus gets 1. 1 gets put in there and we print out 1. Then this frame disappears because the function is over. This local variable goes away, but none, being the immutable thing as it is, remains unchanged in that location that apparently when we call this function, if we don't provide any arguments, then it knows to look for the default value here. In the past, we changed it. None can't be changed. It's immutable. So it's always going to be the same every time. When we call the function again, we call f, we get our new local variable L. It's a reference that points, it knows to point to that place in memory, which is none again. So the next time we call it, L is none, so we create a new object in another place in the heap. Can't modify that, and L changes to that to refer to this thing. And then the second time when we need to modify it, right? Because that's what happens here. And then when we print it, it's going to print just 1 again. So every time we call it, it is going to print 1. And that all stemmed from the fact that none is immutable. And this thing on the right here gets evaluated only once, and that's why it works the way it does. I'm not sure exactly why they chose to do it that way, but that's what we have to work with, and that's a decent model, I think, for understanding it, right? Instead of memorizing the rule and memorizing this idiom, if you forget this code, think of the model. The fact that this thing on the right here, this object, whatever it is, it only gets created once. And every time you call the function, this local variable L is recreated, but it always points over to this object, wherever it is. If you change that object, then the next time you call the function, you get that changed version of the object. But none, because it was immutable, can't be changed. What we ended up doing was creating a new object and saying, L, you get reassigned to that, but that preserves this thing, which allows this to work, because L will be none every time you call the function, at least in the beginning, and then we changed it to this empty array. So if you want it to behave like that, then you have to remember to do something like this. Okay.